Dear student, welcome to this lecture on textile testing. In this lecture, I am going to discuss fabric bending rigidity. Now, before going into the details, let us see what are the topics that we are going to cover in this lecture. The first, I will discuss what is the importance of bending rigidity. Next, what is the mechanism involved in bending. Next, what is the measurement procedures for bending rigidity of a fabric. And lastly, I will discuss what are the factors which affect the bending rigidity of the fabric. Right? So these are the topics that I am going to discuss now. So let us first understand what is the meaning of the word bending. So in order to understand the meaning of the word bending, let us consider a rigid structure. You can imagine the structure is just like a beam, which is fixed at one end and other end loaded on the other. This type of structure is known as cantilever, and if the load is sufficiently high, then this rigid structure will deform and take the shape of a curve in its own plane, right? And we can say the bending has occurred, and the degree of bending is measured by this angle. Okay. Now, if you can see that if this is the section of the beam, upper surface has undergone extension, the lower surfaces or lower layers, you can say, they have undergone compression, and in between this there is a layer which does not undergo any sort of extension as well as compression. This surface is known as neutral surface. Now, in determining the bending rigidity of the fabric, we will follow the cantilever principle, but here direct application of the cantilever principle will be something difficult. That's why we will measure and introduce the concept of bending length. This I will discuss afterwards in the due course of time. And here I am going to now discuss what are the importance of bending rigidity. Now the seam pucker, it is one sort of defect. Now seam pucker decreases with increasing textual rigidity within a reasonable limit, of course, depending upon this fabric weight. That means I can say that if for a given fabric weight, the tendency of the seam pucker will decrease with increasing textual rigidity or bending rigidity. So in this respect, higher bending rigidity within a certain reasonable limit is good. Now, what is seam pucker? So this is a defect that is known as the seam pucker. Okay. Now this is the seam line, and you can see this is the seam line. Okay, and you can see the fabric has gathered over this seam line. Now, if the bending rigidity of the fabric is higher, then there will be more accumulation of the fabric near this line, and you can say the tendency of the seam pucker will be more. Next, lower bending rigidity are prone to create problem in cutting. You know very well that if the fabric is very light, or you can say that if the fabric is very limp, the fabric will always try to deform, and this type of tendency of the deformation will create problem in cutting. Next, fabric with low bending rigidity are difficult to handle on an automatic production line. Next, the fabric with higher bending rigidity are more manageable during sewing. As I have already told you, if the fabrics are a bit stiffer, then you can easily handle the fabric. But if the fabric is very limp, then it is very difficult to manage during stitching. Now, this is one disadvantage of the bending rigidity. Stiffer fabric will be more uncomfortable during wear because it will restrict the motion of the different body parts. You can say like hands, our legs, etc. Now, there are other fabric properties also like drapability, formability, tailorability, etc. This will depend on the bending rigidity. Now, all these terms I will discuss afterwards, like drapability, formability, and the tailorability. So, we can summarize that the bending rigidity is a very important fabric property. It will affect the how easily the fabric can be converted into garment, and the second time it will affect whether the fabric will be comfortable to wear or not. And in this case, the comfort is physical comfort. Okay. Now, higher bending rigidity, in one case it is beneficial because there will be less chance of sympathy. Also, it will be more manageable during stitching. But at the same time, if the bending rigidity is too high, the fabric will be, you can say, stiff, and the physical comfort of the fabric will be poor. Now let us see what is the mechanism of the bending. Now you know that the fabric is made of yarn, and the yarn in its turn is made of fiber. Now when we will try to deform the fabric, or you can say bend the fabric, then the bending resistance of the yarns, which arises out of the bending rigidity of the constituent fibers in the yarn, will try to oppose the bending. Now, what I mean to say in this case, that means the yarn is composed of the fibers. Now, when you try to bend the fabric, then the bending resistance of the yarn will resist the deformation of the bending. Next, the frictional force between the fibers inside the yarn, because of the twist imparted in it, will also try to prevent the bending. Now, the yarn inside the yarn, there are the fibers, and there is cohesion force between the fibers because of the twist imparted on this. And this frictional resistance will also prevent the bending of the fabric. Now, lastly, but it is also very important, the frictional resistance setup between the warp and weft at the crossover point as a result of interlacement between these two, this will also uh, prevent the bending of the fabric. These fibers are under pressure and they cannot slip first against each other. So that means there are three factors which are involved in preventing the bending of the fabric. The first one is, it is basically the bending rigidity of the yarn. Next, it is the frictional force acting between the fibers. And thirdly, it is the interlacement point at the warp and weft. Now, this frictional force is produce a resistive couple, and this resistive couple when overcome by external applied force, then the bending will occur. Now remember one thing, that in order to bend something we need a couple, and here if the couple which is produced because of this frictional force, it will try to prevent the bending, and if the external couple is more than the internal couple developed because of the frictional force, the fabric will bend. Now let us see what is the measurement principle of the bending rigidity. As I have already told, here also we will apply the cantilever principle, but here we cannot measure the bending rigidity directly. Here we have to apply and apply the concept of bending length. The bending length is the length of the fabric that the fabric will bend under its own weight and related to the angle that the fabric makes to the horizontal by the following reaction. That means you can say that the bending length, the C, and the hanging length L, these two are related by these complicated functions. Now, what is the bending length? Bending length is the length of the fabric which is bent under its own weight up to making a certain angle. And what is the L? Here L is the hanging length. You can say so that this is the angle. Okay, this is the angle. This L is the overhanging length. Okay, and this C and L, these two are related to each other by this function, that is cos half theta divided by 8 tan theta raised to the power 1 by 3. Now, in this test, a horizontal strip of the fabric is clamped at one end and the rest of the strip is allowed to hang under its own weight. The relationship among the length of the overhanging strip L the angle theta that it bends to the to and make this angle with this straight line, and the flexural rigidity fabric mass per unit area is given by the following equation. So let us see here. G is the flexural rigidity of the fabric, M is the mass per unit area, and here L is the length of the overhanging strip, that you can see that this is the length of the overhanging strip, and theta is the angle which is made by the this length with this angle. Okay. Now this is measured in an instrument that is known as a Charlie stiffness tester. So this is the sample size. You have to cut the sample, at least 3 samples parallel to the work and 3 samples parallel to the weight. Okay. Now what is the sample size? It should be 25 millimeter wide and 200 millimeter long. And at the time of cutting the sample, we have to ensure that no two warp specimen contain the same warp threads. Okay, and two wave thread specimen contain the same wave threads. Okay, and also we have to uh, eliminate the crease and the twisting part, and we have to ensure that the fabric that is cut should not have any crease and the twisting and folding tendency. Now at least 2 reading are to be taken. One is from the face up, another one is a face down. That means one is a face up, another one is the back. So again I am telling you have to take at least 3 samples along the warp, along the wave direction. The sample size will be 25 millimeter into 200 millimeter, and for each sample we have to test the face as well as the back side. Now this is the principle of bending rigidity. You can say the rectangular strip of the fabric is supported on a horizontal platform. So this is the strip of the fabric. This green color is the strip of the fabric, and the strip is moved in the direction to its length by using a ruler. So this is the black color. This is the ruler, and using this ruler, the fabric is moved forward till it bends and touch this slide. The overhanging length is determined when the leading edge of the test piece reaches a plane passing through the edge of the platform and inclined to an angle 41.5 degree. See, this line is making an angle 41.5 degree below the horizon. Okay. That means you have to ensure that this angle is 41.5 degree. And why it is 41.5 degree? That is, I have earlier shown you that the function is a very complicated function, but if you put theta is equal to 41.5 degree, then the value of this function will be half. So in that case, the C will be just equal to the half of the overhanging. Okay. So I am talking about this function. I am talking about this function. If you put value theta here as a 41.5 degree, for 41.5 degree, the value of theta will be half. So you can say that the C will be L by 2, or you can say by measuring the hanging length and dividing it by 2, you can get the bending length. So this is the Charlie stiffness tester. This is the inclined plane, right? And this makes an angle 41.5 degree. This is the ruler and this is the fabric. Now when you slide the ruler in the forward direction, the fabric will bend and it will touch. And you have to note what is the length of the fabric that is overhanging from this free end and touch this angle. You can see that what is exactly what I have told. The tip of the specimen reaches an angle inclined at 41.5 degree below the horizontal, and the overhanging length is then twice the bending length. Okay. This angle is used in the Charlie apparatus to increase the sensitivity of the length measurement, and the slide on the instrument is directly calibrated in the centimeter. Now, as I have already told you, for theta is equal to 41.5 degree, the value of this function will be 0.5. So C is equal to L into 0.5, or you can say L is equal to 2 into C. So what is the value of L? That will be 2 into C. Okay. Now the flexural rigidity is measured of the stiffness associated with the handle. The flexural rigidity, this is the formula for the flexural rigidity. G is equal to M into CQ into 9.807 into 10 to the power minus 6 micronewton meter. Now bending rigidity, it is basically its unit should be always force into distance. So micronewton is the force and meter is the distance. Okay, and C is the bending length. As usual, I have told you C is the bending length and M is the fabric mass per unit area. So in this regard, I would like to mention one thing, that in some popular testing book, the unit is mentioned as gram per centimeter, but that is not correct. Okay, it should be either gram centimeter or it should be micronewton per meter in the SI system. So better you will always use this unit micronewton meter, because flexural rigidity is a measure of the couple and the unit of couple is force into distance. So ultimately it will come and micronewton is the force and the meter is the distance. Now let us see what are the factors which affect the bending rigidity. We will discuss the effect of the fiber, we will discuss the effect of the yarn and effect of the uh, fabric construction, and lastly we will discuss how does the finishing method affects the bending rigidity. So first you can say the fiber, the two important parameters that affect the bending rigidity of the fabric is the stiffness of the fiber. That means, as I have already told you, that the fiber is the building block of the fabric. So higher the stiffness of the fiber, more will be the textural rigidity of the fabric. Next is the fiber fineness. If the fibers are coarser, then the yarn will become stiffer, and so also the fabric. Now the effect of the yarn. Now spinning system has got a very good effect on the bending rigidity of the fabric. So let us consider two yarn. One is spun in ring spinning system, another is spun in the air jet spinning system. Now from the structure of the air jet spinning system, you know that there are two parts in the air jet yarn. In one is the core fibers. The core fibers are almost parallel to the axis of the yarn, and there is the wrapper fibers. Now these wrapper fibers wrap the fibers, and because of this wrapping, the fibers cannot move with respect to each other, or you can say the wrapper fibers causes the restriction of the movement of the fibers, or indirectly you can say the degree of freedom of the movement of the fibers will be reduced. So as a result, the air jet yarn are stiffer with comparison to the ring yarn, and so also the fabric made from the air jet yarn will be stiffer with comparison to the fabric made out of ring yarn. Similarly, you can say the case of the rotorium. Rotorium fabric also gives the higher fabric bending rigidity on account of its higher bulk equivalent to the ring spun yarn. Now, in the case of the rotor spun yarn, it is bulkier. Okay, that's why its coarseness is that's why its diameter is more or equivalent count, and this will gives the higher bending rigidity. But always remember that if you compare the bending rigidity of the fabrics, then the fabric which is made out of the air jet yarn is always stiffer in comparison to that made out of ring yarn as well as the rotor. Now next is the twist factor. Twist factor is also plays a very important role, because why we are applying the twist onto the yarn? To impart the cohesion among the fibers. So when there is a cohesion among the fibers, the frictional contact with the fibers will be more, and this will also prevent the bending. But if the angle is very high, then this may facilitate the bending of the yarn. Next is the fabric. The plain woven fabrics have higher flexural rigidity than twill and the satin fabrics, because you can see that in the case of the plain fabric, the number of interlacement is higher than that of twill and satin. Okay, and this flexural rigidity increases with increase in the also the end and peak density irrespective of the fabric construction. So there are two important things as far as the fabric is concerned. First of all, what is the construction of the fabric? Is it a plain weave or twill or satin weave? So if the number of interlacement is more, then the fabric will be stiffer. And also if you go on increasing the number of yarn either in the warp or in the wave direction, then also the fabric will become stiffer. Now next is the effect of after treatment and finishing. Now what is the here? As usual, I will discuss the effect of anti-grease resin and the effect of softening, because these two are the common ingredients that are used in the finishing of the fabric. Now if you apply softener, then the bending rigidity of the fabric will be reduced drastically. Why? Because softener nowadays are modified amino silicon softener, and this amino silicon softener is an emulsion of both microemulsion and macroemulsion. Now microemulsion, as the name implies, the sizes are very small and they can penetrate inside the yarn and they can lubricate the fibers. And similarly, the macro emulsion, they will remain inside they will remain outside the surface of the yarn and they will reduce the friction between the yarn. So because of the application of the softener, fiber to fiber friction as well as the yarn to yarn friction will be reduced, and as a result the bending rigidity of the fabric will also be reduced. Next is the effect of anti-crease resin. Now what the anti-crease resin does exactly with the fabric? The anti-crease resin, they will form hydrogen bond with the hydroxyl group. As a result of formation of the bond, the movement will be restricted. And since the movement will be restricted, the bending rigidity will be high. Okay, so this is all about the bending rigidity, and the next we will discuss the uh, other properties of the fabric like fabric thickness, drape, etc. Okay, all this.